Alright, here are your homework solutions to composite functions, building functions, and so on. So number one, you're given two functions, f and g, and you're asked first to add them. So if you're going to add them, all you need to do is combine like terms. We have x squared, nothing else, 2x and negative x, they get combined. That's 1x, and then 5. Done. Now when you subtract, you got to be careful. So maybe we need to write it down. So for g, we have 5 subtract x. For f, we have x squared plus 2x. And just make sure, and I'm going to put the most powerful, that subtract sign gets distributed. So the power term is negative x squared. Next, we have negative x subtract 2x. So be careful, that's negative 3x. And then 5 subtract nothing, which is just 5. Here, that dot means you're multiplying. So we're going to distribute. Most of you are probably comfortable either foiling or drawing an area model to be able to distribute. So that's x squared plus 2x and 5 subtract x, and then multiply it out. So we have 5x squared, 10x, negative x cubed, and negative 2x squared. So I'm going to make it most powerful. So negative x cubed is the most powerful. Then we have 3x squared and 10x. For d, we're dividing. So the numerator is x squared plus, no, the numerator is, 5 subtract x, that's g. The denominator is x squared plus 2x. You could factor and see if there's a common factor that would divide out. But when you factor out an x, I don't see anything that would divide out that would make that simpler. And the denominator is more powerful, so I think that would be it. You can just check something quick. Oh, it also said for each new function, can you state its domain? So this is a polynomial. That would mean the domain is all real numbers. This is a polynomial. That means all real numbers. See, what I'm looking for is, are there any variables in the denominator? Are there any variables under even root? That's what I'm looking for. Here, polynomial, so it's all real numbers. But here, do you see the denominator? You can clearly see what x can't equal, 0 and negative 2. So what made this different is it became a rational where the denominator can't be 0. There's my domain restrictions. All right, number 2, we're going to do it again. So now we have some rationals and fractions, something more fun. So can you add them together? So g is 4x cubed over 5. F is 2 over x. Do you remember how to add when the denominators aren't the same? We need common denominators. So what does the second denominator have that the first one needs? So I need to multiply it by x. The second one needs a 5, top and bottom, so that the denominators are the same. So the common denominator is 5x. And then I have 4x to the 4th minus 10. There's nothing that would simplify that. To understand the domain, look at the denominator, and you can tell that x cannot equal 0. B, let's subtract. Again, the same 2. So we already have common denominator, so why not use it? So 4x to the 4th. And when you subtract, well, what's the difference? Or is this subtracting? Did I add it accidentally? What did I do? You're adding, so it's negative 2 over x. I got this. So when you add and it's negative 2 over x, the positive and the negative is going to be negative. Here, we have the same thing, but we're subtracting. And so when you get to that point where you are subtracting a negative, so we have the same common denominators, right? I'm just using what I did before, but instead of adding, I'm subtracting. So the two negatives actually will just make the same answer, but adding. And again, x can't equal 0. Multiply. So negative 2 over x times 4x cubed over 5. So look to see if we can simplify this. So the x makes the x cubed into an x squared, and that's it. So it's negative 8x squared, and it's over 5. So remember, there's a 1 left over. So the rule is we multiply the tops together and the bottoms. Divide. Well, do you remember when we divide fractions? So f is first. So I write down negative 2 over x. But instead of dividing, I'm going to multiply it times the reciprocal. So it'll be 5 over 4x cubed. Look to see, well, the 2 makes the 4 into a 2, and that's it. So it's negative 5, and then we have a 2x to the 4th on the bottom. And again, x can't equal 0. Number 3, now we have some radicals, so it's a different way of thinking through what we're going to do. All right, let's add them together. Well, you can only add like radicals. So the square root of x subtract 7 and root 2x are not. So all you can do is add them together to put them beside each other because they're not like radicals. Now, what would the domain be? To find the domain, understand the 0 of what's underneath the square root. So the first one, what makes it 0 is 7, and the second one, what makes it 0 is 0. So I need to look at both separately and realize that this one covers this one. So the domain of the first one would be greater than or equal to 7, or from 7 to infinity. Here, we're going from 0 to infinity. So let's back up. It's 7, then that overlaps, that's the one we want. So in other words, what would happen if I plugged in a number between 0 and 7? Would it change this? So understand that any number between 0 and 7 would make this undefined. So therefore, I'm going to take the larger number, 7, and for both, that would be true. So you have to look at both together. So this by itself, it would be 0 or bigger. This one by itself would be 7 or bigger. And then look at the numbers between 0 and 7. They don't work for the first one, so they don't work at all. So that what works for both is 7 and bigger. Let's look at it again. Subtract. Again, when you subtract, they're unlike, so they can only go beside each other. Oh, what's the order? Let's do the order, right? G is first, so it's root 2x. Subtract root x subtract 7. They're unlike. Now again, the same concept here and the same one. So you look at 0 and 7 and realize that 7 to infinity works for both. 0 to infinity won't work here for the second one. So we need 7 to infinity and both would be satisfied. Multiply. So root x subtract 7 times root 2x. So I multiply what's underneath the roots together. So in other words, I'm going to go 2x times x minus 7. When I do that, I get 2x squared subtract 14x. So look at what makes it 0. So again, the concept here is look at the zeros underneath the square root sign. So what makes this 0 is 0, and again, positive 7. If I plug in a number that's between 0 and 7, then it's going to lead to a negative answer underneath. So one answer is that it's greater than or equal to 7. There's actually two parts to this, and in the answer key it doesn't show both parts. So one part is definitely it goes from 7 to infinity. But there's another part also, and that part is if both are negative, that again would make a negative times a negative would allow this to happen. So the second part is when are they both negative so that we can see that. So anytime I put a negative number in, it will be a negative times a negative. So that means also from negative infinity to 0, not including 0, is also included. So that's telling me any negative number works because a negative times a negative would make it a positive under the square root sign. I know, a little confusing. All right, G divided by F. So G on top, F underneath. So that's this understanding, right? So we know the denominator can't be 0, And what's the 0 on top? So this one's a little different because of the denominator. So when I look at the denominator, it can't be 0, but we're also taking the square root, and we got to be careful about this in the same way that I just was careful here. So I have an understanding that 7 or bigger works, because if I plug in, and 7 can't be included, so sorry, so that's that. Because if 7's included, 7 take away 7 makes it undefined. So any number bigger than 7 would work, because you'd have a positive answer. But any number from negative infinity to 0 would also work, because then you would have a negative divided by a negative. And in this example, 0 could actually be included. I know this doesn't show it in the answer key, but this is the correct answer in terms of the whole domain. Turn the page. All right, this is the big one, is what does that little O mean? And that little donut means composed by. So we would read this as G composed by F at X. This is a substitution question. And what I'm going to do is I'm going to take F and I'm going to plug it into G. So start with G, but take out the X and instead put in X squared subtract 5X. So do a substitution and then still have the plus 1. So I took F and I plugged it inside of G. You could also write this as 3x squared minus 15x plus 1. The domain of this, it's a polynomial, so it's all real numbers. I know it looks like hog, which would be great, but it's H composed by G. That means G is going to be plugged into H. So H is what I'm going to start with. And where there's an X, I think it's good practice that where there's an X, put in parentheses first. Then, the next step, G goes in where the parentheses are. So G is 3x plus 1. So start with H, take out the X's, put in parentheses, and then inside, put what G is. Now we're going to simplify it. So 1 take away 1 leaves me with 3x, and then I have a 3x plus 1. I can't cross out the 3x's because one's a binomial and one's just a monomial. So there's your answer. And then what can x not be? So what's the 0 of the denominator? So subtract 1 and divide by 3, and it's negative a third. Again, start with f. So when I look at f, wherever there's an x, put in parentheses. So instead of x squared, take away 5x. Take out the x and put in parentheses. Inside is g, which is 3x plus 1. You could multiply it out. You get 9x squared. You get 3x and 3x, which is 6x. You get a 1. You get negative 15x and negative 5. Then you can combine like terms and get negative 9x and negative 4. It's a polynomial. It's all real numbers. Number 5. H composed by F. So we're going to start with H. Where there's an x, put in parentheses, and then put f in for inside the parentheses. So substitute in. So f is x cubed plus 6. So that would be 2x cubed. That would be 12. Take away 5, which is 7. Again, it's a polynomial, so it's all real numbers. Here, again, it's not hog. H composed by G. So start with H. There's H. So take out the x and put in parentheses. Inside the parentheses, put in G, which is the cube root of 4x. And there's no real way to simplify it. Know that a cube root is all real numbers. So negatives in 0 doesn't bother it. So this is all real numbers. G composed by F. Start with G. That's the cube root of 4. And then inside 4, you have an x. So take out the x and put in parentheses. Now, inside the parentheses, put in f, which is x cubed plus 6. So you could write this as 4x cubed plus 24. It's a cube root, so it's all real numbers. Number 6, use the given functions to evaluate each function. So this time we actually have a number to evaluate in. So we're going to set it up the same way. We're going to start with f, and, well, here, this means the same as plug negative 5 in, plug negative 5 in, and then subtract your answers. So if I start with negative 5 into f, get an answer. So that's 25 plus 20, which equals 40. Plug negative 5 into g. That's 2 subtract 3 times negative 5. So a negative times a negative is positive. So it's 15 plus 2, which is 17. And then you are subtracting those two answers. So 40 subtract 17. So the answer is 28. So again, we're going to go g at 3. So we're going to plug 3 into g and get an answer. So that's 2 take away 9, which is negative 7. Then I'm going to plug 3 into f and get 3 squared minus 4 times 3. So 9 take away 12, which is negative 3. Then I'm going to multiply the two answers together and get 21. For a composition, understand this means the same as, and that might give you an understanding of what we're going to do first. So first we're going to plug negative 6 into h, and then whatever answer that is, I plug it into g. So negative 6 into h. So h is 3 divided by negative 6. So that's negative a half. And then whatever answer that is, I take that answer and plug it into g. And g is 2 times negative 3, negative a half. So a negative times a negative, you can get common denominators. Understand it's 1.5, so this is really 3.5, or 7 over 2. All right, HOF, Hall of Fame, H composed by F at 2. So we're going to start with F at 2 and get an answer. So we're going to go 2 squared minus 4 times 2. That's 4 take away 8, which is negative 4. Then I'm going to take that answer and plug it into into h. So take negative 4, plug it into h, and get 3 divided by negative 4. I can't reduce it down, and that's your answer. All right, how about find two functions, f and g, such that when you compose them together, it equals h. So I need to look and understand. Look at the parentheses and look what's inside. So what's inside the parentheses is going to be my g. So g at x definitely equals 3x minus 1. And that would mean f at x, if I took out the parentheses and worked backwards, so take out parentheses and the 3x minus 1 and just put in x in its place, and then you would have them both. Again, we're trying to work backwards here. So g at x. So what are the things that I notice? So I look at the denominator, and what do I see in the denominator is x plus 5. That means f at x then would be negative 3 over x plus 7. So this would then plug into the bottom. All right, Mr. G Math, over and out. You did your homework. Great job. Over and out.